I am Jonathan Salvietti from the University of Siena, and in the next 10 minutes, I will introduce you to the contents of the course on haptics. The objective of the course are here reported. We will give to educators a fundamental grasp of current technologies and applications for haptic in STEM education, and we will introduce educators to with development tools to produce haptic augmented experiences, and we will provide educators with the knowledge and skills that are required to construct haptic augmented experiences for using in the classroom, and we will finally investigate best practice with haptic augmented experiences in education to understand how it might improve student learning and engagement. The outcomes of the course are 6 and are here reported. We want to identify haptic content that might be used for STEM education, compare different haptic content that may be used for STEM education, utilize different haptic tools that might be used for STEM education, analyze different haptic tools that might be used for STEM, assess different haptic contents that may be used for STEM, and finally create different haptic contents that may be used for STEM. So let's start from the definition of haptics. So haptic perception is the process of recognizing object through touch. Haptic perception derives from the combination between the tactile perception given by objects on the surface of the skin. The conformation and roughness of the objects are read, and the proprioception, which derives from the position of the hand with respect to the object. So touch is a very, very important aspect of our daily life. Here I reported some pictures where we can see how the sense of touch is really, is with us in most of the time during the day. When we born, touch is the sense that we develop first, and it regulates our interaction with the environments and with other people. Still, touch is important for affective relations, is fundamental to discover new experiences like arts, sports, playing music. So we really touch is really important, but if we think to the technology that have been developed, historically, we started from, of course, the sense of sight and from the auditory sense, and then technology comes to touch only later on. Although in many experiences, also in learning, the touch is fundamental. So when we started to talk about technologies for touch, when we discovered and we invented the first robots that were able to reproduce touch. So imagine that here in this picture on the left, we are touching through a pen, we are touching an object. So how we perceive that we are touching this object? We perceive the presence of the object because when we push with the pen on the object is following the Newton law, replicates to the force that we are doing with an opposite force that is proportional to the force that we are applying. So if we now remove the real object and we place a robot that is able to reproduce exactly the same force in the same direction, for the sense of touch, we are touching exactly that object. So haptic interfaces are these robots that can provide with the exact forces that we would perceive when interacting with a real object. Here we see one of the first experiments that we have done in Siena, where actually haptic interfaces were used in a surgical setup to move remote robot that were performing brain surgery. So in this case, the haptic interface let us perceive what the needle that you see on the right is measuring while entering in the brain. And this is really important for surgeon while doing brain surgery. So as we see, the devices that I show up to now are what we call the commercial devices, and basically they are robots. In this case, here is a robot from fourth dimension, and these robots are usually precise and really with an high affordability, but of course they are encumbrant. The encumbrance is not, I mean, is high, and you can see here that with a very small workspace, we need actually a quite big robot, and the cost still is really high. So if we look at this, we are in the order of 20k euros. So the cost is important to be, to be think as a device that can be used by students in a course. So what we focused with our research is to exploit not exactly all the aspect of touch, but to focus on cutaneous sensation. You can see here, this is a very famous video from Professor Johansson, where the girl here has his skin anesthetized. So she can move the hand, she can move all the fingers, the skeleton muscles, but she doesn't perceive nothing through the skin that is anesthetized. And the girl is asked to remove from this pot, remove the objects. And as you can see here, even a simple task like this is very, very complicated when there is no cutaneous sensation. So our receptors in the skin are really important for touch. So the idea that we have at the University of Siena was to focus on this idea of cutaneous sensation and bring to wearability also the sense of touch. You see, this is a process that in the history has been done for audio, and you see that classic hi-fi system have been brought to portable handset. And of course, for the sense of sight, a similar approach has been done with screens that are now wearable screens with these VR related devices, and for haptic interface, this could be the same process. So we want to bring something that is normally confined in our desktop and bring it to something that is wearable and portable. So here we have an example of wearable haptics. So the devices are now not grounded on the desk, but can be worn as thimbles in our hand, and can be used to interact with objects in a virtual environment. There will be a module of this course completely dedicated to the description of possible application in VR, ER of haptics. Of course, when you use this kind of robots, you have also to take care of the tracking of the end position, and you see this small gray box here that is a lip motion sensor, that is a kind of infrared camera that is used to track the position of the end. So the end of the user is in the virtual environment is represented by this avatar, as you can see in the picture on the left. And once the avatar of your hand touches an object, the devices here are activated and stimulate our skin, deform, indent our skin in the fingers, and we have the perception of touching an object that actually is in virtual reality. You can see here an example where three fingers are equipped with haptic interfaces, and from the picture on the up left, you can see that with classic haptic interfaces, it's not possible or is really difficult to have multiple points of contact with object, while with wearable haptics, we can do a lot of applications with more than one contact point. And this is really important also when we want to design some experience for instance, for some STEM-related subjects in VR/AR. So the possibility of interacting with more than one hand. If you remember in the previous slides when I was describing how we use robots to replicate the sense of touch, there was only a pen and the whole hand was touching this. In this case, you see that is the whole hand that can interact with the object, performing more than one contact point. What we can do with this? So what are the ideas? And you will see this more in detail in the next lessons, but just to give you an idea. If we have something that can measure the interaction with the environment, then we can transmit the sense of touch. So here you see that there is a device that acts as a microphone to register the interaction with the environment, and in a remote side, there is one of our wearable haptic device that replicate the sensation of touch. So here you can imagine all the application of, for instance, in communication. You can think that you have your video conference system where you can transmit not only voice and images, but you can transmit also touch sensation. Or imagine that you are in a shop and you call at home and you can touch something in the shop and let your wife, maybe that is at home, feeling the same sensation that you're feeling with your hand. Of course, you can also take so you can record tactile sensation, like in this example, where actually tactile sensation are recorded and then are played back with our devices. So you can, it could be a lesson that is recorded with all the haptic sensation and then played remoted. They can be played remotely with all the haptic sensation included. So like a kind of online transmission of touch or record and of a lecture with touch and then a playback in a different video. Or here we can see an example where we use tactile signals to steer a blind person. So imagine that here the blind person has a camera that is showing to a remote operator the way in front of the user, and also the blind person wear two bracelets on the arm with vibrating motor, and the operator remotely can activate these bracelets to suggest direction of motion. This is called usually guidance, and with haptic, so you can imagine that instead of having a blind person, you have students performing something, and you can correct the motion of his arm or his legs using tactile sensations. So this is really a very broad world of possibilities, and in the next lessons, we will give you an idea of the more important tools that can be used for designing wearable applications, and we will also show you the difference between the difference between haptic interfaces, and you will see possible application related to STEM. Bye.